You are here for the Building with Observability webinar using Circle CI and Honeycomb to achieve production excellence. I'm Ryan Pedersen. I am a solutions engineer here at Circle CI, which means I get the fun opportunity to work with customers both pre and post sales, help get onboarded, adopt CI/CD, and then do some more advanced configuration and things in their CI/CD pipeline. I'll hand it off to Pierre.
I'm Pierre Tessier. I'm a solutions architect with Honeycomb. Like Ryan, I also help out customers with their observability journey using Honeycomb, both pre-sales as well as post-sales, to ensure that their journey is optimal and they continue to gain better knowledge of their systems. So with that, let's talk a little bit about what it is to have elite performing teams and what it is to achieve production excellence, if you will, with your engineering teams. There was a DORA State of the DevOps report that they did earlier this year, and they released it. And they came out with some really important kind of things that really highlight what high performing teams do versus the not so high performance ones. And certainly one of the key factors here was deployment frequency. They do multiple deploys per day, and that's key because that allows you to minimize a change, allows you to be more adaptable and get you to where you need to go. And ultimately, they get that lead time to change is lower. And if something does break, restoring their services is much less than an hour. And it's at the top of the class. And their failure rates also go down. And this is all because we do a lot of small incremental changes. But the benefits aren't just for being a high performing team. You get better outcomes from this, better business outcomes, higher market share, greater profitability. Your employees are happier because they're not always on call. They're not always frustrated with their systems. They have speed and stability together. And ultimately, you have a better culture within your organization. We're going to show you today through this presentation on both Circle CI and Honeycomb, how we help organizations achieve this higher deploy frequency and gain better observability within their platforms. And we're going to show you examples of how we do it with each other's platforms ourselves. So with that, let's go look at what today's webinar is going to be all about.
Okay, so before we get into the agenda, a couple housekeeping items. We will have a Q&A at the end. Feel free to ask your questions at any time. If you use the Q&A button at the bottom of the screen, we will definitely see them more easily, but we'll also monitor the chat. We do have live captions for the broadcast. You can see them through the access button on the screen, and we're going to send through a link in the chat as well. So in terms of agenda, here's what we have prepared. We will kick it off with some CI/CD. So intro to Circle CI, some optimizations in Circle CI, CI/CD pipelines. Jump into Honeycomb, observability. What is observability? Then some mutual use cases. So Circle CI using Honeycomb, Honeycomb using Circle CI. We have a demo of Honeycomb, and then a Q&A wrap up. So this is your last opportunity. If this is not what you signed up for, this is an exit ramp. If not, we're looking forward to running this for you. So on to Circle CI. Circle CI, our mission is to empower technology-driven companies to do their best work. We do this by making engineering teams more productive through intelligent automation. And when we say idea to delivery, what we really mean is anything from that ideation stage all the way until the time it hits the hands of the customers. So anything from big features, bug fixes, new products, we help developers and teams focus on what they were hired to do. We handle the automating of the build, test, and deploy. And some background on Circle CI, 9 years old, still growing fast. We have customers in all types of industries, different sizes, at different points in their trajectories, all the way from single developers through building a product, unicorns, Fortune 100. We work with thousands of customers and run millions of builds per day. It means we've seen it all, highly flexible in terms of things that one can do on the platform. And back to that concept of idea to delivery. On the left here in the green, see creation, we see the VCS. That's where all the code lives. Takes all the updates from the developers, ingests it. All the way to the right over here, the other green, the logistics, that's where the code's deployed. Think shipping off a container, deploying to Heroku, deploying to a Kubernetes cluster, really wherever. In the middle part here, this blue, this is Circle CI, automating that building, testing, and delivery of that code. All right, and as I mentioned at the top of the hour, as a solutions engineer at Circle CI, I get to help customers both generally get onboarded, which I think of as ensuring stability and determinism. And then I get their builds optimized and as fast as possible. Really, that speed piece. I'm going to jump here right into some of the level two pieces associated with speed and stability. These are the levers that I often look to pull to drastically shrink the build times and workflow times. Start with a couple of tried and trues, then a newer option, then a way to adhere to best practices and make the config file as simple as possible. The concurrency and parallelism, really easy when to play around with these concepts, concurrency and parallelism. Before I get to those definitions though, a quick definition of a workflow. So for us, a workflow is a dependency graph of jobs, which jobs are running and in which order. A job is usually a specific task to perform, something like a unit testing suite, building a Docker image, running some linting steps. All right, now we got that out of the way. We will talk about concurrency. So look at job 2 and job 3 here. So define concurrency is used when we're just describing jobs being run concurrently. So if you had to run multiple testing suites, something like a unit testing suite, a snapshot testing suite, those can be run side by side. You don't have to wait for one to finish to start the other. For you, that means you're shrinking the amount of time your developers have to wait after pushing code before they get that first piece of feedback. Another level down is parallelism. This is setting the config at the job level. It spins up the specified number of nodes to run that job across. It's really useful in particular for test splitting. We have an internal test splitting mechanism, so it can split up lengthy test suites over whatever defined number of nodes. We optimize that by splitting by timing data so the test suites finish the same time. So think instead of needing to run 1,000 unit tests all sequentially, split those across 30 nodes to drastically speed up that process and get that feedback back to your developer much quicker. So you can also have parallelism set for concurrent jobs, really speeding things up. Another one is playing around with resource classes. It's a really easy one available. Sometimes you just need a little bit more juice. But we covered that a workflow is a dependency graph of jobs that run in a specified order, and each with a single thing in mind. And each job also can be highly flexible in terms of platform, Docker, Mac, VM, custom runner, Windows. But not every task fits into a one size fits all approach with resource size, their CPU and RAM. So you're able to specify different resource classes at a job level. Think a heavy job that needs more CPU and RAM, something like building a Java app. You can specify that, and they can live side by side with one that needs much less, a quick linting job, for instance. One last optimization speed piece, and this is pretty new, is the ability to use RAM disk in jobs. And before I get into the how, I just want to touch on the why. Each job in Circle CI is isolated from one another, but they do all share the local SSD on the EC2 instance. So it could be fighting if you're running jobs with a high number of parallelism over that SSD. It was brought to light with some inconsistencies in installing node modules in particular, which before RAM disk would have to be formed on SSD rather than in memory. But even without this in mind, RAM disk is just plain fast. So what we did in order to solve this piece around determinism and speed is to utilize something Docker containers already have mounted in them, which is RAM disk. So we're able to specify to use these as working directory, and it utilizes Docker and RAM disk and speeds things up, really useful for IO heavy tasks. It can leverage as much memory as available in the specified resource class. So a really great way to marry together resource classes with more speed. All right, and as promised, on to ways to also make life easier and your config cleaner. And you can think of Orbs here, Circle CI's package manager, reusable configuration as code. It is good for a few main use cases. One, which we'll cover mostly, it's a network of certified and partner orbs. Now, these are orbs in our orb registry made by either Circle CI or one of our close partners, someone like Honeycomb. So if you use one of these, you know everything's up to date. They include best practices and their version. Like, think stability, getting your developers back to doing what they do, not trying to reinvent the wheel, figuring out how to use a tool and to implement that in your CI/CD pipeline. They also include the source code so you can see what's happening or repurpose them if you want to make them your own. They consist of commands, executors, or even entire jobs. So you can distill what might have been 30 lines of many lines of code down to a few or single lines of code and use parameters to do what you need to do and make them scalable and useful across use cases. Um, I think instead of having to call an entire script, bash script, you can just simplify that um, and be off to the races. So as promised, we covered some speed and stability levers, many of the level 2 pieces that customers find value in. So now I'm going to hand it back to Pierre.
Awesome. Thanks, Ryan. So, we often talk about Honeycomb. We also talk about observability. And I like to first define what is observability. What does observability mean? Observability means being able to ask any question and getting that answer, even if you don't know what you're looking for. It's not monitoring. I want to be really, really clear here. Monitoring is not equal to observability. You know what else is not equal to observability? 3 different data types. You don't need logs and tracing and metrics to achieve observability. You need to have a different lens on your data to get there. You need to be able to look at that data differently. And we're going to talk a little bit more about that as well. But ultimately, what we want to do is focus on what you need to know, even when it is you don't know what it is you're looking for. So going from that, let's talk about what it is that makes Honeycomb. What is our mission? And what it, so this is observability. So how does Honeycomb apply this to our mission? Ryan? Thanks. So our mission is to give every engineer the observability they need to eliminate the toil and delight their users. Being able to go into your platform and with confidence, knowing we could push that release, because if it is bad, I'll be able to look inside and find out what it is. And I'm not going to struggle to find out what it is. We want to make on-call not be a dirty word for your engineers and your SRE platform. We want to make it so when there is a problem, they don't have to worry about trying to hunt it down or figure it out. They'll be given that answer for them easily. So what makes Honeycomb the platform for observability? What sets us apart from all of this? First off, we have a purpose-made data store for an event-based approach. I said no more thinking of data as traces and logs and metrics. They're all types of telemetry events. And what we want to do is eliminate these 3 pillars and these 3 different tools you need to use and put it all into one tool. So all your data comes in, and no matter how you're trying to slice the data, you could see it all with that same lens. And you want to be able to get there with ridiculously fast queries and no cardinality limits. So it's one thing to come back with a query in a couple seconds or milliseconds, but it's another thing to be able to say, you could push a user ID to your query and group on it. Even if you've got over 100,000, over 1 million, over 10 million users, Honeycomb will perform just fine and still slice the data for you, really allowing you to ask any question across any dimension of the platform. And finally, we want you to take this and wrap it up with service level objectives and have that be the driver for your observability. Raise your hand if you've seen an engineer build a new service and the first thing they did was create a dashboard with 8 charts on it and say, this is what you need to monitor my service. And then when something happened, that dashboard didn't tell you what you need to know. That's because we're built into the psyche that we need to create all these alerts for all these various symptoms. Service level objectives allow us to focus on what the business value of our service was. Why did we create this service? What kind of service did we want to do when we built this product? And then we build our alerting from that. We build our observability from that. So if our service level objectives are struggling, we could use that as a launch pad to learn more. And ultimately, you release alert fatigue. You allow us to focus on what matters within the platform. So look at some of the use cases you can benefit from putting all of these things together with Honeycomb. And the first one is that ongoing development use case. Certainly, if you have better observability, you can get insights into what's going on, and you can continue to build new features and be the first one to market with that brand new thing, not being disrupted, but being the one that does the disruption. Paired together with Circle CI and the confidence that you know what your code is going to do and no fear about it, you get those pain-free releases. I want you to push the button at 5 p.m. on a Friday to release your code. Do it on a Sunday too, because you have the confidence and you'll know that you're fine doing so. Symptoms optimization is another great one. The number of times I've worked with customers where they said, we've instrumented our application with Honeycomb, and wow, we did not know we were calling this query 13 times for a single transaction. That's moving to a cache, right? And just like that, just by gaining those simple insights, they were able to make their applications, make their customers' experiences better. And certainly probably the primary reason why people want to use Honeycomb is for incident response. When something goes wrong, you want to have the system tell you why. You want to be able to know what is going on. So with that, I'm going to hand it back over to Ryan to actually talk about some of these use cases of how we've used Circle CI and Honeycomb together.
Thanks, Pierre. Right, so it takes two to tango. And I'm really excited to talk about some of our mutual use cases. This is also my favorite slide. I love the concept of tangoing and working together. First off, some ways that Circle CI uses Honeycomb. So the first use case I want to touch on is quickly finding things that are out of the ordinary for us. One example recently, we noticed there were some very large spikes in log output hitting Redis in places. And for us, Redis is where the build output collates before it's sent off to S3, before it goes to more permanent storage. So at this point, we have the knowledge something's going on with Redis. Next step is just to figure it out. Sounds easy. Well, it really is using Honeycomb. So we dig into Honeycomb, start going through queries, look for something that stands out, something not like the rest. We take an approach, you'll know it when you see it. And we finally find it. And there's definitely no doubt there's something different here. The graph is what we see in Honeycomb. We finally track down the culprit. We dig into the purple. We're able to see what's causing this. We get as granular as the specific customer on the branch and the commit that caused the first spike, and let us know to look into Redis. Before I tell you what it was, I want to remind you, Circle CI has thousands of customers. We see millions of builds per day. The fact that we're able to so quickly narrow this down to a specific customer commit with Honeycomb is incredible. So we find out the change was due to a Rails upgrade, resulted in a huge amount of deprecation warnings that were flooding the logs. With this information, we're able to go to the customer, let them know what had happened. So just making a change in the code or piping the logs out to artifact storage if they're definitely needed afterwards. But overall, we're able to get to the bottom of a general piece that bubbled up and make some proactive recommendations very quickly with the help of Honeycomb, the visualizations, and using Bubble Up. A second way we use Honeycomb in our day-to-day is by following traces. Some parties strongly recommend not chasing waterfalls, but in this instance, following a waterfall is very helpful. With microservices, there are a lot of services talking to each other, and we're able to use traces to visualize the waterfall of API database calls. In a great example here, while examining a workflow recently, we spotted that we were running some validation calls multiple times for certain conditions. Think what Pierre just mentioned, 13 times for a single transaction. You should do something else with that if you can visualize that. What was interesting is that these are things that could be done only once in an ideal world. So after spotting that, we're able to update work to include a better way to pass what we need in terms of validation between jobs. This reduces the unnecessary calls, which is really helpful for workflows of big fan outs. Think a job running up to 100 parallelism, needing to make a call 100 times, versus just passing it what is needed and doing it once. So we covered off on visibility into the builds being done, as well as our distributed traces, some great Honeycomb use cases from Circle CI. And with that, I'm going to hand it back to Pierre.
Awesome, thanks, Ryan. This is a fun use case I want to talk about. It's really a theme which has been building a lot lately, getting a lot more traction. We're seeing a lot more people wanting to do this, and it's really all about building better builds. And we're going to talk about how we get there. So first off, I'm going to ask people, raise your hand again. How many people have actually been the person in the chair with the sword before? I know we've all been there. I was an engineer a long time ago as well, and I remember saying, "Oh, it's compiling. Go do this and go do something else," right? Certainly now with build systems out there, we push it off to another platform like Circle CI to do that compiling. But it's still something that existed nonetheless. And if we want to think about this a little bit more, what is a build? What do you do in a build? Well, you take a request to create something, you run it through a series of steps or a workflow. Some of these steps happen in parallel. Some of them, kick off in single file, and eventually you end up with an artifact or a set of artifacts at the end of your build. If we think about what is a request going into your application, it comes into a service, it gets serviced by that service, maybe it gets branched off and executed in parallel by other services, and eventually all these services are done and they produced a package and you respond back to the end user with a response. They're really not that dissimilar when you think about what we're doing, which is a series of steps. So what if we take the concepts of distributed tracing? What if we take that and we apply it to builds? So if we could take builds and apply distributed tracing to them, you get something that looks like this. I can see how long my entire build took. I could see what commands were run to do it and how long each command took. We can even see if each individual commands were successful or failure. We could add other attributes as well, like did you produce an artifact, the size of the artifacts. And we can kind of encapsulate all this stuff into a trace. So this looks great. I see a waterfall chart of what looks like a build. How did we get here? Well, Ryan maybe hinted at it earlier on. We built a little utility, we called it build events, and then we wrapped it up with an orb. And we released it over on Circle CI orbs. It's free for anyone to use, and it allows you to add wrappers for every single step in your build workflow, or at least the steps that matter for you, and build out that same waterfall view. So you could understand your builds. So you could understand and gain observability in what's going on in those builds, optimize them, find better ways to do builds or clean them up. And I'd love to actually show you how this works in action of what did Honeycomb do to do this. So let me go ahead and grab the screen and show this off a little bit. So this is Honeycomb right here. This is our environment. We're staring at the Poodle service. We call it Poodle is our front-end service. We name all our services after dog breeds at Honeycomb. It's kind of fun. And what we've got here is all these markers. And what these markers here are actually our deployments. So at Honeycomb, we build all the time. And if there's any new builds, we will deploy every hour on the hour. It's early in the morning. Engineers don't work overnight, but you could see here, we've been deployed late last night. It looks, this is what happens at Honeycomb. So we could go ahead and look at each one of these and click on that deploy, and we'll actually see the Circle CI workflow of how to get there. And I could see here, this deploy was committed. We can get down to the actual git commit if we wanted to, but what happened, what we were doing, adjusted some kind of Lambda flag for us and launched Darkly. And we can see all the steps in that workflow. And this is great. And this is fine. And we get some value there, but this is Honeycomb's build events area. This is where we actually send all the data for all the builds we do. And I've got them kind of plotted out right here. I could come right here, and I'm just going to make this a little bit better for us to see. See all these blocks. These are all the times that we've done a build in the past 24 hours. And again, I could click on each one of these right here, and we'll get that trace of view. And I could see what it was that happened. So this build took 415 seconds. It did some stuff in JavaScript. Let's go ahead and just collapse all these. Oops, I'm so sorry. I'm gonna go ahead and collapse all of these. We can see it did a JavaScript build, did some Go test stuff, and all those same steps you've seen before and those workflows, you can see them all right here with their timings. And each one of them also has other subsets. So we can really understand, where are we spending our times in our builds? Can we make them better? Because if you think about it, a build is compute time. You got to pay for this. It's resource that you're consuming. And if you're trying to be a high performant team, you're going to be doing a lot of builds. You're going to be constantly trying stuff, right? You're going to be doing a lot of integration testing. So you want that to be as optimal as possible. And that's actually something that happened. On October 5th, one of our platform engineers at Honeycomb made a GitHub commit. And it was a pretty big commit. It was the build speed up commit. And we can see here what Dean did, the Honeycomb engineer. Dean added a RAM disk for caching. He put a lot of notes in here, did other optimizations around how we do our JS builds. And we added parallelisms to this as well. So we can take advantage of all these features that Circle CI offers us to make better builds. And this is what happened. So this is about 2 weeks of data, I believe, right here that we're staring at, or maybe 3 weeks of data, which is our build times. And it's over that span of time. And right here, this is October 5th, when that commitment was merged, when Dean pushed that commit. And you can see our build times went from 900-ish seconds down to 500. Significant improvement, 30+% is what we saved. And if you want to think about this, if you're able to save 30% in your build times, this is quantifiable savings that you could have right there, but just really observing your builds, understanding what they are, and applying these techniques from Circle CI to make them better. And you can see, if I could click on any of these dots here, the build tree did drastically change because we went to parallelisms. And we optimized each of these steps to use the RAM disk so they all went faster. So with that, we're going to hand it back over to the presentation here. And we're going to kind of open this up if there's any questions that you may have about the platform or what you've seen so far, about anything you might have around Circle CI, or anything you might have about Honeycomb. What do you do with observability? Feel free to go ahead and ask them right now. We see them in the Q&A, or if you are more comfortable using in chat, you can go ahead and post them in there as well.
I see one around CPU and RAM usage for each job. So the answer is somewhat. So RAM, if you want to get RAM usage on a Docker executor, you can see the high watermark, and I can put the link there in the chat for how to do that. You can cat that out. CPU is not accessible, but definitely kind of feedback that we've heard before. Love to find a way to get that out there.
Awesome. I see another one here coming in about what's the difference between logs and traces with Honeycomb. There is no difference when you bring in that data into Honeycomb. We consider all of that events in our parlance. Certainly a trace has additional attributes associated with those events where we can connect them to other similar log lines, if you will. And really, I like to kind of say the journey from log to tracing is going from when you have log lines, is you're going to have an application running with a lot of different entries going inside there. And when you got to go to debug it, you're looking at all these entries flying through, and you can't really correlate which ones make up a single transaction, because that one transaction would have dumped 25 different entries in your log lines. Well, with tracing tracing is the glue for all of those entries. So when you say pull up that one transaction, it's going to extract all those log lines for you and kind of draw it up. And that's the way I like to kind of say what tracing into or what logging into tracing looks like. But the Honeycomb, you can send either or, and our platform allows you to do everything that you see us do on it. We can't draw a waterfall if it's just log lines, but we can do all the other kind of analysis that we're able to do in Honeycomb. I see another one here, question about publishing, is there an ORB available that allows us to publish our Circle CI jobs into Honeycomb? So you mean maybe like a marker, if you will? Interestingly enough, we probably should produce an ORB for that, but it is a single API call or a single CLI command as well. We do make a CLI available for it, and we publish an image for it. However, duly noted, it probably wouldn't hurt for us to build an ORB to do the same thing. I see another question here. See a chart of total time required per build. We have similar charts showing total compute per build. You can do that. It is something that we could do in Honeycomb, because each step is called out, and I could make a chart just for specific steps, and your steps could be compute steps.
I think we could probably pair that with I have another like a script to systematically get that, like the high watermark of RAM too. We could probably couple those together. So, yeah.
I see a couple more questions here. There's maybe a follow-up to a prior question. You weren't looking to do a marker. You meant an orb to instrument the pipeline. That is what the build events orb is for, is to instrument the pipeline itself. So you use it inside of your CircleCI's config workflow, and for each step that is important for you, you would leverage the orb there. And I do see another question here about data sets for Honeycomb. I will recommend a separate data set for your build stuff. We do that at Honeycomb ourselves. It's called build events, fittingly. I recommend you call it the same thing. I think that's actually the default associated with the orb. So there's not any more questions. Certainly thank everybody very much. I hope you found this informative. And if you'd love to learn more, go ahead, Ryan.
I was going to say, for us, we would love to come out of this just excited about speed, stability, but also just as excited about digging into the orb. So check out our developer hub, the orb registry, get up and running.
So if you enjoyed all this and you want to learn more about Honeycomb, we offer you plenty of different ways to learn more. We offer observability office hours with our developer advocates, Liz Hong Jones and Shelly Spies. They're wonderful. They offer great advice. And even if you're not a Honeycomb customer, if you're just looking for general observability office hours advice, go ahead and give them a ring. They're there for you. Every week, we provide a fun weekly live demo. If you want to see more in depth of Honeycomb, it's every Thursday at the same time. I believe it's 10 a.m. Pacific, 1 p.m. Eastern time. And if you want to try Honeycomb, you can try for free. We do have a free tier. It's great for anybody to try it out. It's a little bit limited in the number of events you could send, but it's absolutely there. It's free. It'll be free for you to use. And if you're ready to grow and scale, we'll be there with you as well. And on that note, thank you very much. Remember, test your code in production, because that is the only spot where it actually lives and where it actually is real. And build often with CircleCI.
Thanks very much.